All right, great. So today we'll talk about data. Oh, I still can't get over this fat marker here. But okay, so we'll talk about data, types of data, and organizing data, as well as collecting data. Okay. Okay, so we can think of data as information generally organized. And on Monday I talked about how the big idea of statistics is that we have some kind of population that's too big to be observed directly, so we take a little piece out of it, and then we magnify that, or we just we study that little piece, which we call the sample. Okay, so in statistics, whenever we have data, it's almost always referring to the data from a sample. Okay, so data will almost always come from a sample. And so when we talk about looking at a sample of data, each observation, or let me just talk about, we can arrange the data from our sample into a data table. And so each observation in our sample will have a row in the data table. Or the observations can also be called observational units. Each observational unit okay, and so we will have one row for each observation for a total of n rows. N is our sample size. So basically, how many observations are included in your sample? It's going to be April in 2 days here. The years go by quickly, don't they? Anyone graduating this quarter? Yeah, all right. So pass all your classes, right? and then off to the real world. That's the fun part. Sort of. Okay. You'll love it. So one row for each observation for a total of n rows. Okay, and then each piece of information that we collect each piece of information that we collect for each observation is a variable. Okay, and so, for example, we can say our sample is our classroom, okay? It's not really a sample that's representative of anything, but we could treat it as a sample of data, okay? So we could say our sample is our class of students. Okay, and we have something around, 170 students. Okay, and so we can say, we're going to gather pieces of information. So we'll look at your name for each student, your name, your sex, your height, and we'll say hand dominance. Okay, and so so we can start off with, I don't know, I'm just going to make up names here, all right? Tracy is female. She is 5'3", so that will be 63 inches, and she is right-handed. Oh, let's throw in another column here. We'll say age. And she is 21 years old. Okay, and then we have Eric, who is male. He is 6 feet tall. He's also right-handed and is 19. Whatever, okay. And so on and so forth. So I'm going to just have arrows down for a total of 170 rows. Okay, so we have stuff like this. Now, as far as these column headings go, each column heading, or each column, is a variable. Each row is an observation. Okay, so in our data table, did I skip too quickly to the next slide? Are we okay? Yeah, we're okay. All right. In our data table, each column is a variable. Each row an observation. Okay, and then so we will say we have two types of variables. Okay, we have categorical variables. And these tell us what type or what kind. And then we have numeric variables. And numeric variables tell us how much or how many. Okay. So from our the previous table, our column headings were name, sex, height, hand dominance, and age. Okay, and so if we were to label these as either categorical or numeric, we would say name is categorical. Now, some texts will say there's a special kind. This is an identifier, okay? But we can also just treat it as a categorical variable. Sex would be categorical. Height would be numeric, because it tells us how tall, how many inches tall someone is. Hand dominance would be categorical. And age would be numeric. Okay. Well, that's assuming age is being recorded as a number. Okay. So if age is recorded as, you know, the number of years of someone's age, then it's a numeric variable. So, for example, 19 or 24 or 45 years old. Okay. On the other hand, age, if you're something like a polling organization or Nielsen Research or whatever, age can be recorded as a category. Okay. Okay, so you could be in the 18 to 24 demographic, or you could be in the 25 through, 49, or the 50 to 65 or something. They've got little demographic categories based on your age. Okay, so in this case, this is now a categorical variable, right? So how the variable is recorded is important, okay? And on the other hand, we have variables that appear as if they are numeric, but in reality, they are categorical because they do not tell us what type or what kind. So, for example, if we look at someone's area code on their telephone, we've got, the 310 area code and 213 and 818, et cetera, et cetera, et cetera, 626. We've got all these numbers here, okay, but it does not make sense for you to say, oh, my friend, he has 126 area code less than me, ha ha ha. That doesn't make sense, okay? They are numbers, but they do not tell us how much or how many, okay? So they are numbers, but do not tell us how much or how many. So in reality, they are just labels, okay? So really, they are just labels which make them categorical variables. Okay, so far so good. All right, so by the end of the quarter, well, it should be pretty clear what's a numeric or a categorical variable, and it's very important that you can distinguish between what a numeric and what a categorical variable is. Okay. All right, let's say we can summarize our data, okay? Okay, and so, so summarize our data with tables. So the first way we are going to look at this is we are going to look at the frequency table. Okay, it's just, you know, a type of summary table. Okay, and so what we can do is we can take our entire data table for the class and just kind of boil it down to just a few rows here, okay? Okay, and so we can say if there's 180 students total, maybe 85 are male, which makes 95 females. Okay? All right. If this is our summary table, you know, contrast this to what would the actual data table, how many rows would exist in the actual data table? So this table, there's just 3 rows, right? Male, female, and total. The actual data table would have how many rows? It would have 180 rows, right? Because we have one for every single observation, and here if we have a total of 180 people represented in our summary table, then that means there must be 180 rows in our actual data table. Does that make sense? Okay? And so, you know, maybe you don't want to look at the entire table with 180 rows, okay? You know, if you were, you know, working in some company and they asked you to print out, you know, a summary of the data, they would be upset if you printed out an Excel sheet with 180 rows that takes up, you know, 6 pages. That would be rather annoying. So instead, you would boil it down to a frequency table, which just kind of gives you the count of how many males and how many females they have. We can create a relative frequency table, which basically, instead of just the count or the frequency, we would turn it into a percentage, okay? And so instead of 85, we would say 85 divided by 180, and we would get something like 47.2%. Okay? And so if we have 47.2% and everything has to add up to 100%, how much goes over here? (52.8%), right? And I mean, we could verify this ourselves and do 95 divided by 180, but and we would see indeed we get 52.8%. But we can also figure that out if you know, if everything adds up to 100, and you know, this assumes that everyone identifies as either male or female. But if that's what we have, then this is what we've got. Okay, so that's a frequency table or a relative frequency table if you're dealing with relative frequencies. Okay, and we can also create a two-way table. Okay, so a two-way table is basically a frequency table, but for two categorical variables. Okay, and so in this case, we will have sex, male and female. And then we will have hand dominance, so we'll say left-handed versus right-handed. Okay. And so we can fill out some of these numbers, like our total numbers here. Okay, so for males, we have a total of 85, and females we have a total of 95 for a total of 180, okay? And then we just have to say, well, how many left-handed males are there? I don't know, 13, okay? And that makes the right-handed males, how many would there then be? We would have 72, okay? Make up another number over here, I don't know, 16. So 95 minus 16, 79. Okay, so 13 plus 16 adds up to 29, and 72 plus 79 adds up to 151. Okay, and so this is a two-way table, and basically we have just added a second categorical variable. So we have sex going this way, and then we have, I guess, hand dominance going that way. And it tells us whatever. This is what we have, okay? And so based on this, we can then ask questions, okay? We can say, what percent of males are left-handed? And I'm just gonna abbreviate it LH. Okay, so what percentage of males are left-handed? Okay, and so what would the fraction be that I need to do to calculate this? 13 divided by 85, right? Okay, so we do 13 over 85. We get 15.3%. Okay, and contrast this question to what percentage of left-handed people are male. Okay, and so what would the fraction there be? 13 over 29. Okay, 13 over 29, and we would get 44.8. Okay, and then contrast that further still with what percentage of all students in the class are left-handed males. Left-handed and male. And the answer to that would be 13 divided by 180. 7.2%. Okay. And so, you know, these questions all sound kind of similar, but they're also, you know, if we look at the answers to each question, they're all very different from each other as well. So, so please make sure you understand the difference between, you know, this question versus this question versus this question. Okay. Are there any questions on this? So far, so good? All right. Okay, and so this is one way to summarize our data. Okay, quick question. What kind of data have we summarized here? Numeric or categorical? Okay, so this is a summary of categorical data. Okay, so both the frequency table and our two-way table that we have here, these are summaries of categorical data. Okay, so you know, don't just because we've got counts here, you know, we've got 85 males and 95 females and et cetera, et cetera, et cetera, that that doesn't make it suddenly numeric. It's the whether someone is male or female, that's a categorical variable. Whether someone is left-handed or right-handed, that is a categorical variable. Yes, you're going to have numbers, you're going to have counts of these things, but if we think of the underlying data table and the type of data that's being stored and being summarized, it's categorical data. Okay, let's talk about gathering and collecting data. Okay, so so one way that that we see data. Maybe I can just sit down. Oh my gosh, this is so much better. Okay, I'm gonna do this from now. Standing. Who is gonna do that? All right. Okay, let's see. Get the viewing angle right here. Okay, so gathering. Oh my gosh, this stool is going to change my life. Gathering and collecting data. Okay, so we've got anecdotal data, okay, or anecdotal evidence, I should say. Okay, so anecdotal evidence, this is based on stories, or so for example, customer testimonials. And they can be very convincing, but from a statistical standpoint, we can't do anything useful with anecdotal data, okay? Okay, so from a okay, so this is, you know, for example, someone says, you know, my aunt had this illness, and so she saw this special doctor who gave her this slightly unconventional treatment, and it worked, and she got better, okay? We're not discounting or discrediting what happened, but these isolated stories, from a statistical perspective, there's not much we can do with it, okay? And so, you know, yeah, it's hard to it's hard to do anything from a statistical perspective when you're dealing with anecdotal data, okay? So as far as data that we can do use statistics for, we have observational studies and we have experiments, okay? So I'm going to talk about observational studies first, and then I'll talk about experiments, okay? So with an observational study, observe our subjects. We try not to interfere with our subjects with the exception of taking measurements, okay? Still so excited about this stool. Okay, so yeah, because on Monday I was like, oh my gosh, my feet, they're dying. So we try not to interfere with our subjects with the exception of taking measurements. Okay, ideally we can take measurements on all variables that could be related to the phenomenon that we're trying to study. Okay. And at the end of an observational study, we might be able to say that one variable is associated with a particular outcome. Okay, we might be able to say that a certain variable is associated with a certain outcome. Okay, do not say that one variable causes the outcome. Okay. Okay, and that's because all we've done is observe. So, you know, a silly example is perhaps you were, you know, an alien from another planet or something, and you didn't know much about human life or human culture, and so, but you do know, you know, when someone is alive or dead, and so maybe you're hanging out at a hospital, okay? And what you do is you're just observing, and what you notice is that sometimes there is a man wearing black, carrying a book, and sometimes he will enter a person's room, and then he will say something, and then shortly after, the patient in the room dies. Okay. And you observe this consistently happening, okay? And you might think, oh my goodness, this guy is using his words and killing off patients, okay? But because, you know, we're familiar with, you know, certain religious traditions and things, you know, there's a lot of times if a patient is doing poorly, you might ask a priest or pastor to pray over the patient before he or she passes. And so so it's not that the pastor or priest's words or prayers is killing the patient, but rather that the patient's deteriorating condition causes the pastor or priest to come to the room. But if you were just an observer watching this happen, it could be tempting to draw the conclusion that that it's the words or the prayers that are killing off people. Okay, and so, you know, from an observational study where you're only observing things happen, you can't make causal conclusions. Okay, but you can say that there's an association between, I don't know, the kind of the tradition of, you know, the final rites or last rites and increased death rate or something like that. You could say something like that. So we can say that there's an association, but you cannot say that one causes the other. On the other hand, we have experiments. And perhaps controlled experiments is a better way to describe this. So with controlled experiments, the researcher assigns treatment conditions to the subjects or participants. Okay. Ideally, the researcher can assign identical conditions to everyone with the exception of the treatment. Okay, the researcher can identical conditions on all aspects related to the outcome. Okay, can assign identical conditions to the subjects with the exception of the treatment. Okay, so for example, you know, it would be nice if we could take all of our volunteers, all of our participants, and so let's say we were interested if a new medication is effective in lowering someone's blood pressure. Okay, now there are lots of things that could go into affecting someone's blood pressure: their age, their sex, their amount of exercise, their weight, the type of nutrition they get, and all sorts of things could go into affecting someone's blood pressure. And so for under our ideal experiment, we would have, you know, identical groups of people, and all of these people are subject to the same exercise regimen. They all have the same diet. They all have the same, you know, type of work, and they all have everything's exactly the same. And then we just say, okay, we're going to split you up into two groups. This group's going to get placebo. This group over here is going to get the medication, okay? And because everything's exactly the same, at the end of the study, if we see that there's a difference between our two groups, we can say this group was different and this group was different. That difference can be attributed to the fact that this group got placebo and this group got the medication, okay? Because everything else about these people's lives were controlled in such a way to be exactly the same, okay? On the other hand, if you did not do a proper setup, and you did something really dumb, like you stick all of the men in one group and all of the women in another group, okay? And then you give the men's group the medication and you give the women's group the placebo. At the end of the study, if you find out there's a difference between this group and this group, you don't know if that difference is because this group was men and this group was women, or if the difference is because this group got the placebo and this group got the medication, okay? And so in that case, you have what you call a confounding variable, meaning you don't know if the difference is because of the difference in treatments or the difference is because of something else going on, okay? So under ideal experimental conditions, you have the two groups identical as possible, the only difference being the treatments, and then therefore, at the end of the experiment, differences in the outcome can be attributed to the difference in treatments. Does that make sense? Okay, so I'll just kind of write a short summary of that. Okay, so we'll say differences in outcome can be attributed to differences between treatments because all other aspects of variation were made identical for the participants. Okay. So, just in your reading, look at treatment variable, or look up treatment, look up confounding variable. Okay. And placebos are used to help make conditions identical. Okay, so placebos are used so that the psychological condition between the treatment and experimental groups, the knowledge of whether they're using the actual drug or the placebo, that is can be made identical across both groups. Okay, to make the quote the psychology of the experiment the same. Okay, so the key point here would be that observational studies can only lead to conclusions about association, whereas experiments can lead to cause and effect conclusions. Okay, that covers it for today. You guys have a lab tomorrow, and we'll see you guys on Friday.